the concept of superconductivity. When a substance is cooled to a sufficiently low temperature, the electrical resistance of the substance drops suddenly to zero. This phenomena is called superconductivity. Why do materials have different resistivity? As a general rule, resistivity is strongly influenced by the temperature and the nature of the material. As a result, we have here 8 different materials in the tabular column categorized by the resistivity value. The behavior of some type of materials here is almost unidentical values despite their similarity. Generally, resistivity depends strongly on temperature. A metal such as copper or silver exhibits a linear relationship with different temperature around or equivalent to room temperature, but it depends on the nature and the crystal structure of the material. Therefore, using these materials will be able to understand. The ability of contact electric current is a characteristic property of every materials like silver, copper, gold, aluminum, calcium, tungsten, zinc, and cobalt. Each of the every materials and it can be used to compare various materials. So just those materials which behave as electrical resistivity, which means R is equal to not zero. Therefore, those materials to consider as a normal material or non-conductive material. However, resistivity is a material property of the conductor. Actually, it depends only on the temperature of the conductor and not on the length, density, or cross-sectional area of the material. As a result, increasing the length increases the resistance of the body but not the resistivity. So simply we can see the graph explain just about what is the length, density, and the cross-sectional area of the material. Resistance is something you are aware of. It is inevitable that all materials resist the flow of current to some extent. Two broad categories can be distinguished. One is an insulator, another one is a conductor. Insulators are plastic, rubber, glass, paper, wood or examples. So those insular materials have high resistance value because of the flow of current is very low. In addition, the conductors are copper, gold, silver, and aluminum are examples. Those conductor materials have low resistance value because of the current flow is high. In this section, we discuss the supercapacitor concept. Before to discuss, as we know now that what is electrical resistance, what is insulator, and what is a conductor. Now we are talking about the supercapacitor in the particular section. Keep in mind there is a phrase in the textbook that says low temperature, which is quite confusing for us. However, thus I will try to explain the difference between the transaction temperature and the critical temperature. Remember, we are matching the temperature based on the Kelvin scale of a supercapacitor. Therefore, we are measuring the temperature here, but how are we measuring it? According of the three different scales, these are the Kelvin, Fahrenheit, and Celsius. One rationale we heard is that Celsius is a scientific scale, whereas Fahrenheit is a human scale. So, which means, as we know, the Celsius scale, the range 0 degree to 100 degrees Celsius, the interval is 100 degrees. Fahrenheit is scale from 32 Fahrenheit to 112 Fahrenheit. The interval is 180 degrees. Here is the what I would say about the difference between critical temperature and transition temperature. The critical temperature of a substance can be defined as a high temperature at which the substance can exist as a liquid. At the temperature above the critical temperature, the substance is question can be no longer be liquefied. So which means the condition state is a vapor or gaseous states. Therefore, regardless of the amount of pressure applied to it. Transition temperature. Material transition temperature are those that which crystal state changes. A temperature at which two crystallized form of a substance coexist in equilibrium is known as an equilibrium temperature. However, we can now easily understand the difference between the two different temperatures. I hope as a result we have a question. Why is the transition temperature calculated in Kelvin form? To deeply understand the critical temperature, it is very important to have a look at a graph. According to the SI unit, temperature versus pressure is measured in kelvins and bars. Once the temperature increasing gradually, it reached minimum some extents at the particular stage is called triple point. Because when a substance, solids, liquids, and gases form change equally at the same temperature and pressure, the quantity of each remains constant. Therefore, to increase the temperature, we will raise it up to 300 to 315 Kelvin, which is nearly 77 degrees Celsius. Consequently, the end point of a phase equilibrium curve is called a critical point or critical state in thermodynamics. There is a liquid vapor critical point, which is the point on the pressure temperature curve, where a liquid and its vapor can coexist. The sake of, for the sake of clarity, the triple point represents a temperature and pressure combination, where all three states of matter exist in equilibrium. Therefore, critical point is the temperature and pressure combination where the gas form as a substance can no longer be considered back to liquid, which becomes a supercritical fluid. Once again, we have a question: why is the transition temperature calculated in Kelvin scale? Due to fact that all the gases are liquid at 0 degree Kelvin, it is also known as a absolute zero. In fact, Kelvin scale of temperature is regarded as a better scale than Celsius because the Kelvin scale temperature is used by scientists. They wanted a temperature scale to measure exact zero reflect the complete absence of thermal energy. Happy to hear to talk about Fahrenheit and Celsius scale were both based on water, either the freezing point or boiling point or a combination of water and chemicals. The following figures is easily explained to understand the ranges of difference from one to another parameters. Roughly to compare, the highest temperature in 100 degrees Celsius means Fahrenheit equally 212 degree Fahrenheit. In Kelvin scale, equivalently 373 Kelvin. At the same time, 0 degree Celsius means in Fahrenheit 32 degree Fahrenheit, comparatively in Kelvin is equivalent to minus 273 Kelvin. Most commonly, these scales are used to measure water boiling point to check the body temperature of humans, as well as the level of the freezing point during winter condition can be identified. By simple understanding absolute zero values, we can understand what they mean. As we can understand what the Kelvin scale is used for. Usually, Kelvin is used in lighting to determine the coloring temperature. Following figures as explained, an object Kelvin temperature is related to the physical temperature with use of the lighting applications such as white, blue, and red colors. Currently, we are in the final stage of this presentation. Our questions remains the same. You can see from the graph that there is a difference between what is a substance and what is a temperature, what does resistance means, what is superconductivity. It is my hope that it will help the concept. Simply to say the structure that has completely disappeared when the temperature is raised. I would like to repeat again what is superconductivity. Superconductivity means the structure has completely disappeared when the temperature is raised. To conclude, I would like to thank you for watching my channel. I greatly appreciate of your support through comments, shares and subscriptions. Thank you.